Assalamu alaikum. My name is Ahmed Afzal, and I am your assistant on this course on artificial intelligence and Python for basic image processing by Dr. Naveed Bakr. In this video, we will simply recap everything that we learned on day one. So, hey, we started off with a basic introduction to our instructor himself, in which we set the tone by understanding what we can expect from this course and how it can open up doors for endless possibilities. So, what we did today was simply introduce ourselves to Colab by Google. Now, what is Colab? A Colab is basically an environment or a place where you can code with Python, code and create with Python without any systemic restrictions. Then we in Colab did Hello World. We did the Hello World for biological sciences, and then at the end, we had a bit of a teaser towards the endless possibilities with artificial intelligence. So, hey, let's get to work. So, on your browser, write Colab Research Google, right? Just write that in. This is the first thing that pops up colab.research.google.com. Just click on that and this is the thing that will pop up. Welcome to Colab. So hey, let's get rid of all of this text, make our workspace a bit clearer. So as it's saying, Colab allows you to write and execute Python in your browser. That's awesome. So let's just clear up our space, and here we are, blank. How do we get started? Press this button right here, which is code. This is what you'll have. Start coding. So what will be our hello world? Let's say I'll give you a problem. I have a big DNA sequence. And what I want is to find out, the number of nucleotides in it. And I also want to find out the number of nucleotides, let's say how many adenine nucleotides are there, right? If there was a sequence of, let's say, even 100 nucleotides, it would be a bit of a tedious task to individually go through the whole 100 nucleotides to find out how many adenine nucleotides are there, right? It would be a tedious task. How do I make it easier for myself? How do I get something else to do my work? So that's where coding comes in. So let's say I have this variable. Now, what is that variable? It's called our DNA sequence, right? Variable called DNA sequence. And I'm going to input that DNA sequence. So, please enter DNA sequence, a colon and a space. And hey, that's basically my fundamental command. Now, if I press this play button right here, it's simply going to spit out anything that I put in. Please enter DNA sequence, and I have this box to write my DNA sequence in, right? But this would do nothing right now because hey, I've not given it a task to perform. So hey, let's go ahead and do just that. So A is 0, T is 0. So adenine, you know, thymine, guanine, my 4 nucleotides, and cytosine, right? Now what would my task be? So for the nucleotide entity in this variable called DNA sequence, and now look at the importance of a colon. The colon would basically make sure that there is some space in the other line, in the next line. How is that helpful? That is helpful to create a loop. Now, creating a loop makes the command, follow through to the next line, right? That's basically it. So, if nucleotide, I hope this is easy to follow. If nucleotide is A, like let's say there's an A present, right, in the sequence, I want it to add an A. Like I want it to A plus 1. What do I mean by that? So let's say there's a DNA sequence and it has adenine in it. When it spots the adenine, I want it to add plus 1. So if there's one adenine, plus 1, two adenine, plus 2, right? So on and so forth. So, you know, this is basic. This is the basic command that I put. If I enter a DNA sequence right now, it wouldn't do anything because, hey, I've just given it a command. I haven't asked it to produce something out of it. Where does it produce it? Where does it give it? Where does it give it my output? It's going to print it out. So first off, we have to exit from the loop. How do we exit from the loop? Press enter a couple of times and then backspace. Okay, I'm going to print my output. So print the count of nucleotide A is, yeah, and make sure you stay in the bracket, comma A. Okay, now if I enter my DNA sequence, right, let's say my DNA sequence is AGTAG GTGGA, just write anything, okay? I'm just having fun with it. Okay, I'm gonna press enter and see the magic happen. Okay, so let's say this was my basic code. And look at that. The count of nucleotide A is 6. Let's see if that's true. So A, 1A, 2A, 3A, 4A, 5A, and 6A, right? 1, 2, 3, 4, 5, and 6, right? So that is how I perform a very basic function, right? To find out the count of nucleotide A in a DNA sequence. How awesome is that? How simple is that? Now, I want not just A, I want time into, I want the count of guanine too. How do I do that? I simply replicate this command for each and every nucleotide. So I simply copy and paste. Now, how do you do that? It's Control C on your Windows laptop or computer, or Command C on your Mac. And to paste, it's Control V on Windows and Command V on Mac. So I do it 4 times for the nucleotide, and now this is not enough, because right now it will give me the output for adenine 4 times. That's not what I want. I want thymine, cytosine, and guanine. So I'll simply replace the A with the T. So everywhere A is written, I'll replace it with the T. And I'll do that in the next sequence. I'll do it for C. Just follow along. I'm sure this is not difficult to follow along. I hope this makes sense. And finally, G. So here's that. So how fun was that? How simple was that? Now let's go ahead. Let's enter the DNA sequence. Let's make this big. GTA, GAC, GCA, GCB, not GCB, GCA, GCC, GTA, GAG, GTG. I'm just making this as big as I can. So when you're done typing it out, press enter. And would you look at that? So voila. Count of nucleotide A is 14, nucleotide T is 8, nucleotide C is 9, and nucleotide G is 17. So hey, it performed the function in mere seconds. How awesome is that? And this is just the beginning. This is our hello world. So, this was fun and all. I agree. Quite fun. How about we take it to the next level? How about we spice things up? Right? Click on code again. What's written? Start coding or generate with AI. So the above this everything that we have written, this is how coding was done not until, a few years ago. Right now, you can do this, generate with AI. Um, Now, what you have to generate is simply write down the problem that you're facing. So, what was our problem? Our problem was to find out the number of nucleotides in a DNA sequence, right? So, I want this thing to write me a Python code that would ask a user to input a DNA sequence and count individual nucleotides in it, right? That's my problem. And just press enter and just look at that. It's generated the entire code for you. Now, of course, this looks different to the one that we wrote, but I'm sure that this will give us the same result. So let's put it to the test. Let's run it. It's asking me to enter a DNA sequence. So let's write it down. AGA, GCC, GCA, HCG, TGA, TGC, all of that. Just have fun with it and press enter. And would you look at that? Would you look at that? So A is 13, T is 5, C is 6, G is 12. Magical. So, writing this code took me, let's say, 5 minutes. Having AI solve this problem, write this code for me, took 5 seconds. How awesome is that? So, hey, that was it. So, this is just the beginning. This is the tip of the iceberg. We have so much more to look forward to in the coming lessons, and I can't wait for them. So, hey, I hope that you are just as excited as I am. That's about it. I hope this recap helped you out. And in the following video, you'll see just a bit of a teaser to what, you know, all of this is capable of. Because, hey, this is just, you know, a very small glimpse. That's about it. If you need any help at all, if this was difficult to follow, if there's any problem that you face while following this, please don't hesitate to reach out to me or my other partner who's also called Ahmed, and we'll be happy to help you out. So, hey, that's about it. I hope you have an amazing day. Assalamu alaikum. Allah Hafiz.
So I was doing something. Yeah. So you know this this program that is called the School of Biotechnology, right? That department head, Avid, be careful now. Listen to this, Dr. Mushtaq. He has established a lab called Fly Lab. They do a lot of research with this fly called Dorsophila. So I understood what they do there. So I wrote a program and I created a data table. I used 12 flies, fly number 1 to 12, and
Wow.
I treated them with four different carcinogens. So I treated one, two, three fly numbers. with carcinogen A's. The number one, I gave it low dose of exposure to the carcinogen. Number two, medium dosage. And number three, fly number three was treated with carcinogen A, but in high exposure quantity, or exposure level. Same thing, low, medium, high for the next three flies. And then low, medium, high for the next three and next three. You get it?
Yeah.
Now, based on that, I wanted to see the wing length. So I noticed that fly number one, which was treated with carcinogen A in low quantity, had a wingspan of 2.1 millimeter. The one that was treated with medium had a wingspan of 1.8. The one that was treated with high carcinogen had a wingspan of 1.5. And this goes on with the next three flies, the next three flies, and the next three flies. Okay. And then I did the filament count. Filament count are the bristles on top of the wings. So the first one that was treated with low exposure level of carcinogen A had 25,000 of those bristles. The next one with medium carcinogen had 20,000, and the last one was 15,000. Okay, so this is my data set. This is my table. Based on this table, I asked to write descriptive statistics for the wing length and the filament count. And then I asked it to run an advanced statistical analysis called ANOVA. ANOVA is called analysis of variance. And it printed me those results. And then I asked it to also create graphs for me. Okay. And it
Yeah.
created box plots and pair plots, and then converted categorical data into numeric data for correlation matrix, and then
Heat map.
heat map to show correlations, and then additional descriptive visualization with histograms, and lastly, box plots for descriptive statistics. And when I run this program, this is the result that I get. Descriptive statistics, the count, mean, standard deviation, min, max, and then 25, 50%, and 75% level. Then descriptive statistics for filament count. And then I do a NOVA test. So if you know anything about statistics, you would know what F statistics mean and what P value means.
Yeah.
Did a F statistics and P value for wing length and the filament count. And then these are the visualizations of those graphs. These are the box plots. These are with different carcinogens. This is fly ID, wing length. You see all these? And then the data is shown with different carcinogens. And then the heat maps of correlations. After correlations, we've got our normal curve for the descriptive statistics and the box plot for wing length and filament count. Right? So all of that was done here. So